Hello, Johnny Angel back again with another AMOS Pro video. This time we're going to be talking about joysticks and how to control a character on your screen by using the joystick commands which are built into AMOS. So we're going to be looking at commands like Jleft, Jright, Jup, Jdown, and there's even a test for pressing the fire button as well. So let's get on with it. But first of all, there are two things I need to let you know about this video. One, I'm going to show you a very rudimentary way to get the joystick commands to register and how you can control a very basic character on the screen and move it around. In real terms, you'd never actually do this in the real world, but it will show you the theory and the functionality behind it. Secondly, hang on until the end of the video because I'm going to show you where this is going to lead to and where a future video will pick up using the joystick to control graphics that we load into AMOS. Bobs, as it were, how to control a bob object on the screen and how to move it around. That's where we're going. So sit tight, go through the tutorial and wait until the end. Right, here we are in some code. So I've already created the comments here on this program. So when you can download this from my website and you'll have all the comments in here already done. If I'm looking off to the right, it's because I have a listing of the code on my laptop and I'm reading from there because I can't remember it all off the top of my head. So let's get going with this. So the first thing we need to do is set our screen up. So this time we're going to do a screen open 1. We're going to make this a little bit smaller this time, 320 by 200. We'll have it 16 colors and we'll have it as low res. Previous screens I usually open as high res, but this time we're doing this as low res. We can do paper 7 and we can clear the screen. You can also do CLS 7, will give you the same effect, but I do it this way. What we're going to do then is turn off our cursor. We're also going to issue the command hide, and I'm going to put this comment in here because this hides the mouse pointer. Strange, it's just hide on its own, just does the mouse pointer. Okay. We also are going to need to use a command, double buffer. And I will show you what happens when we don't use this. But effectively, double buffer, I'm going to need to read this out the AMOS manual. Basically, AMOS employs a technique known as double buffering. The double buffer command creates an invisible copy of the current screen and stores it as a logical screen. All graphics operations, including bob movements, are now performed directly on this logical screen without disturbing your existing display at all. It's kind of important and it's a bit of a deal breaker if you don't use it. So we need to have it here. So with that command issued, we can now go and set up some variables and miscellaneous bits. So I've got some variables. One is called HPOS, which I'm using for horizontal position, and I'm setting that to 20. I've got VPOS, which is vertical position, and I'm setting that to 10. I've also got a string here, which is just a space, and we'll understand why I use that in a minute. Right, cup of tea time. You've got to have tea when you're coding. Right, so what I need to do now, I'm putting in a quick locate command, 0, 0. This is just a bit of a reminder. You don't have to put this in. This is just purely something I dropped in because I kept forgetting. Press fire to exit the program. And we'll see what that does in a minute. Right, next thing, we need our control loop. So what I'm going to do here, we'll just put in a quick do loop. And what we're going to do is print a character on the screen. Just a basic text character. So I'm going to do locate HPOS, VPOS. So that's our horizontal and vertical positions. And I'm going to print open speech marks, space, exclamation mark, space, close speech marks. Okay. Then I'm going to do a locate 0, 2. This is not mandatory to get this working, but this is just for reference so you can see what's going on. Print heading, heading, and we'll have this as a space after there, close quotes. And then we'll just do hstring. Okay, what this is going to do is just purely show us which way we're going, up, down, left, right, etc. Now here comes the fun part, boys and girls. We're now going to check the joystick to see if the joystick's been moved. So I'm going to issue the command if Jleft 1. So Jleft 1 is basically joystick in port 1. So if that has been activated, what we need to do then is set hstring to left. This is just for your own reference. I need to put some spaces after here as well, because I'm just printing left, right, up, down on the same space, and sometimes it just gets a little bit muddled, a little bit cluttered rather. Then what we need to do is adjust the position, our horizontal position. So hpos equal hpos -1, because we're going left. So if I now end if, okay, so let's see if that works. So basically what I'm doing here then, if left joystick is actioned, print, you're going to print up, well, we're now heading left, but then we're going to adjust the value of hpos, so our exclamation mark that is printed on the screen should move back one position to the left. So quick F2, oh, I've got a syntax error, yep. Good old fat thumbs and fingers while typing, there we go. No errors on that, got the indentation right, so let's press F1. So this is what I've got. So here I've got an exclamation mark. So now if I push the joystick to the left, we see the heading is now changed to left, and we're moving left. Look at that. Our exclamation mark is moving left. So it won't move anywhere else because we've only programmed it to go left at the moment. Now I need to Control C to end that program, and let's put some more movement in. So what I need to do now is check for write. So if Jright, joystick 1, hstring equals write, a couple of spaces after that. Now what's going to happen to hpos? So horizontal position will equal horizontal position +1, because we're going the opposite direction. No errors, let's run that. So we know that we can go left, but now we should be able to go right. Look at that, we can go right. Isn't that good? Got our little character moving around the screen there, left and right. And the heading at the top of the screen is changing as well. We can't press fire to exit the program because we haven't written that code yet. So now we need to move up and down. So now we can do is if j up 1, if j up 1, and now hstring equals up, a few spaces after that. Now we need to change vpos. Vpos equals vpos and -1, because we're now going back up the screen. And if, okay, no errors, let's check that. So now we should be able to, we can go left, we can go right, and now we should be able to go up. And look what's happening. We're leaving a trail. We're leaving an exclamation marky trail behind us. So, quick mouthful of tea. We need to do something about that. And what we can do about that, you'll probably notice back up here, I put a space either side of the exclamation mark, and that's to stop the exclamation mark from leaving a trail when it goes left and right, because there's a space either side of it. We've not been able to put a space above it or below it, and we need to do that now as part of moving vertically around the screen. So what I'm going to do is just quickly type this command in. So we'll do a quick locate hpos, vpos. Oops, my mouse is in the way again. Sorry people who comment about that, I do apologize. And what we'll do is +1, yeah, and then we're going to print some spaces. 3 spaces will do, 1, 2, 3. So what we've done here is we've actually taken our vertical position and subtracted 1 from it to move the exclamation mark, but where it's come from will be a +1 value, and that should now print a space on that spot. So let's run that. So I can go left, I can go right, let's go up. Look at that. there's no trail being left behind now, because what's happening is as we're moving up the screen, the vertical position to print our exclamation mark has changed here with the vpos -1, but in the position it was at, which will be vpos +1, we're now printing a blank space. Happy? Right, let's go down. If jdown 1, so h string equals down, a couple of spaces after that, and vpos equal vpos +1, because we're going in the opposite direction. And what we now need to do here is our locate command again. Well, I'm not going to type that. I was going to show you this. If you hit Control B, which gets you into block mode, and then with your cursor, just highlight that line of text. Now, if you do Control S to store that, and you'll see that it says block stored in memory. Well, it did anyway. Now we come down to the place where we want to paste that. This is basically our Control C, Control V on modern computers. If I do Control P, it's going to dump that line in there. I don't want to do it at the plus position, this printing this blank space. I need to do it at the minus position because we've gone down the screen, and where we were, there'll be an exclamation mark, and I need to go back to that spot and just print a blank space. And then here, oops, I can just do an end if, and I'll just use F3 to tidy that code up. And I'm going to give this Amiga S to save it. Right, let's do it. So we can go left, we can go right, we can go up without leaving a trail, and now we can go down the screen without leaving a trail. We are moving an exclamation mark around the screen using our joystick and some very simple code. Yes, it's a little bit lumpy, it's not very smooth, it's not very slick, but like I said, this is the rudimentary code to show you how to get this to work. This, in my mind, is also very reminiscent of what you would have done back in like a Spectrum or an 8-bit machine back in the day. You know, with user-defined graphics and whatnot, moving that character around the screen in Spectrum Basic. That's what I used to do, and it was this lumpy. But, you know, we'll advance this, and I'm going to show you what it can look like later on. Oh, look at that. I can go diagonally as well. So if I pull the joystick down diagonally, we can move diagonally around the screen as well. So AMOS really has these joystick commands sorted out. So I still don't have fire set up, so if I just Control C to drop out of that, and now what I need to do here, I'm going to literally just do this command, F equals fire1. So I'm going to set the value of the fire button to a value called F, and then here I'll do is if F equals, and the command to check the fire button is -1, okay? We won't bother printing anything else. We're just literally going to exit the program, end if, let me just F3 that. Outside the loop, I'm going to put the end command. I'm going to save that. I'm going to press F1 to run. So we're going to go left, and now I'm going to press the fire button, press the right fire button, and the program will end. Simple, isn't it? So there we have it. We are checking for the fire button by using the F equals -1 command, then we'll exit the program and we end. But very, very simple stuff. We can go left, we can go right, we can go up, we can go down, we can press the fire button, and all of that works. So I'll just give it one more run for you, just so you can see there's no witchcraft involved. We go left, we go right, we go up, or we go diagonally up, we can go up, we can go down, and then we press the fire button and we exit the program. All of that is working. Happy days. So where is this going? So this is a program which I've kind of got working for our next video. Look at this. Is that a yawning angel avatar on the screen? What happens when I move the joystick? Look, it moves as well. And look how smooth and how fluid it is as it moves around the screen. Yes, this is a graphic which I brought into AMOS using the object editor, created an objects bank, and we've read that image from that bank, and we're using the joystick to control it on the screen. It is way smoother than what we've just done. In the next video, I'm going to show you how to do this, but please be aware you had to see this video in order to understand the fundamentals of getting the joystick to work and to be understood by the program so you can manipulate something on the screen. This is where we're going. So the next video, we're going to cover this. And that's it for another video. Thank you ever so much for watching. Don't forget the source code for this program will be available on my website. There's a link showing up down here, hopefully. Go to the downloads page and grab the code. Like I said, this is just a rudimentary way of getting this working. And in the next video, we're going to look at doing something a little bit more advanced, but at least we've got the joystick commands wrapped up and we understand those. Thanks ever so much for your time. Like I said, thank you for watching. I do a load of these AMOS videos. There'll be a link up here somewhere taking you back to those, the rest of them in the series. If you like what I do, please subscribe to my channel. I'm on KoFi as well, and if you like what I do and want to buy me a coffee, that'd be great too. No obligation. I really appreciate you watching these, and thanks once again for all your wonderful comments about these videos. You really do inspire me to keep going with these, and I really enjoy doing them, and I really enjoy sharing this information with you. So until the next one, take care of yourselves, look after everyone around you, and keep it retro.